Moving on to question number A4. Section A, question number 4. One end of a long metallic wire of length L is tied to the ceiling. The other end is tied to a massless spring of spring constant K. So we have a long string coming from the roof, one end of which is tied to the roof like this. The length of the string is given, capital letter L. And then to the free end, you are connecting a spring of spring constant K, spring constant K. Then a mass M hangs freely from the free end of the spring. There is a mass suspended over here. This is mass M. And then what is the question? The area of cross section and Young's modulus are A and Y respectively. If the mass is slightly pulled down and released, you are just pulling this down and releasing it. Now what happens then? If you pull it slightly and release it, it will keep oscillating vertically, right? These are vertical oscillations. It will oscillate with the time period equal to. So I'll repeat the question here. We have a light string that is suspended from the roof. The length of the string is L, and there is a spring attached to the free end of it. The spring has a spring constant of K, and there is a mass attached at the other end. This mass is being pulled and released, so it will execute vertical oscillations. All right, you're expected to find the time period of oscillations here. Now, before moving into this, I'll tell you, this is sort of a series combination of springs. I can take this as a series combination of a spring and a string. Oh, so for this one, I can call the spring constant as, say, small letter k. For this one, it is capital letter K. So as per the combination equation, 1 by Ks is equal to 1 by K1 plus 1 by K2 should be taken. Okay. So for finding the effective in series combination, the equation is 1 by Ks is equal to 1 by K1 plus 1 by K2. So 1 by K1 is how much? 1 by K1. I can put it as 1 by K plus 1 by K2. K2 is capital letter K. Look at this. K1 is that of the string, which is small letter K. So I'm replacing K1 with small letter K. And then K2 is that of the spring, which is capital letter K. So I can put capital letter K over here. And if you come back over here, Young's modulus is given by FL divided by AL. This is the equation for Young's modulus that you learn in mechanical properties of solids. F is the force that you apply. You are applying a force at the free end here. This is the force that you are applying. L is the actual length of the string, and small l is the change in length for the string. There is an extension for the string. When you pull it, there is a slight extension for the rod or the string here, and that extension is small letter L. Area of cross section is A. The area of cross section here is called A, capital letter A, area of cross section for this. So, and when you stretch it, obviously there is a restoring force. I can find restoring force from this. So what is the force here? Force is, if I cross multiply, I get Y A L over L. But since you are more concerned about restoring force here, restoring force means when I stretch it and release it, it will automatically restore its configuration, right? This happens because as I stretch it, as I apply a force on the string, there is an equal and opposite force developed inside the string in the opposite direction. That is called restoring force, equal and opposite force. Opposite means I need to attach a negative sign. Now, if I take this as equation number 1, general equation for force is minus K into L, equation number 2. This is the general equation for force. Force is written as minus K into L, where K is the force constant. And if you compare these equations, comparing 1 and 2, if you compare 1 and 2, what do we get now? You know, F, in place of F you got F here, in place of L it is L, and for K we have a replacement here that is YA by L. So I can put it here, so K will be YA divided by capital letter L. So I can put it straight to this equation. 1 by small letter K is YA by L plus 1 by capital letter K. Taking reciprocal, it is L by YA plus 1 by K. This is 1 by Ks. So I can take the LCM here and find the reciprocal. What is LCM? I'm writing here. LCM is, if I take LCM, it is YAK, K goes here and YA goes here. So it is KL plus YA. KS is equal to, if I take LCM here and take reciprocal, what I'm going to get is, look at this, YAK will go to numerator, YAK will go to numerator, divided by, this is KL plus YA, KL plus YA, KL plus YA. This is the effective force constant I have. Now I can put in the equation for time period. Time period of oscillation of the system is given by 2 pi root of m by k. 2 pi root of m by k. This is actually Ks I'm talking about, because I need to take the combination of spring and string. So if I put it here, T is equal to 2 pi into root of m over, this is YAK by KL plus YA. YAK divided by KL plus YA. One more time, taking the reciprocal, that will give you 2 pi into root of m into KL plus YA divided by YAK. This is the time period of oscillations of the system of spring and string in series combination. Here, out of the given options, option B is correct. 2 pi into root of m into YA plus KL divided by YAK. Is that clearly understood?